So I thought this would be interesting. So Plumbers is one of the few conferences where there is contribution from contributions about AOSP, and there were a bunch of people from Google giving presentations. So since not everybody can go to Plumbers, it's relatively expensive, and you've got to be there. Plus, there are a limited number of tickets. I thought I'd just give you a quick view as to what we were talking about. And I was pretty fortunate myself to get a place at Plumbers. The tickets until the very end were kind of hard to come by, and then they suddenly had found a bunch under the sofa somewhere. So a lot of people managed to go see it. So Plumbers is every 12 months, and the concept behind it is the place where the kernel developers and people using Linux directly get together to talk about basically both sides of that interface. So we have the people implementing the kernel APIs, and we have the people using those APIs. My particular interest has been with the Android Micro Conference, which has been run for the last 10 years or so. And so that's mostly what my focus is. Whole bunch more about Linux Plumbers. The LPC events gives you overall information about the conference. If you want to see the talks, you can look at the raw video feeds. So if you follow that link there, I hope, you see the raw video feeds, but they haven't been edited yet, which means there's a lot of pauses, a lot of people staring at the camera saying, "Can you hear me?" And yeah, when it comes to a break, it still records the breaks, even though there's nobody in the room. Sooner or later, probably sooner, somebody will edit those down into something a bit more usable. But for the moment, you just got that. So part of Plumbers is divided into micro conferences on particular aspects of Linux. And here we have the Android Micro Conference run by Karim Yagmour, and he's been doing this for about 10 years. So the micro conference is a 3.5 hours. It was an afternoon on the Tuesday, in fact, where we got a bunch of people together to talk about Android, or specifically the Android kernel. I'm not going through every single talk. Some of them I felt were a little specialized and not relevant to a more general bunch of people. But again, if you want to see the whole lot, click on that link I show there. So the topics I've picked up on are, let me just double check how I'm going. Oh, I've only got 4 minutes left. The topics I've picked up on are, first of all, GKI. So this was a talk from a guy from Qualcomm. And the good news here is he was talking about GKI, the generic kernel image, which is the idea of having a common kernel across all Android devices. And the nice thing I felt was that Qualcomm are 100% behind this, and they're shipping GKI kernels based on Android 12 and Linux 5.10, which is basically last year's Android. And they're currently working on Android 13 and Linux 5.15. There was some talk about the fact they have to do, or they have been doing mixed builds. So they actually are building the VM Linux from the Android common kernel. So that's the GKI kernel. Apologies for all the acronyms. But curiously, they are building the modules. Well, maybe not curiously. They're building modules from the Qualcomm source tree, which maybe isn't too surprising. The benefit from Qualcomm's point of view is that they are closer to upstream Linux, and they are able to push patches out much more quickly, which is a good thing. In the Q&A, there was some discussion about devices with low RAM. And there was some issue, which I don't think is a big deal, but currently with devices with say 1 GB of RAM, which is typically the Wear OS stuff, that's the smartwatches, they tend to use Android 32 kernels, not, they tend to use ARM 32 kernels, not ARM 64 for size reasons. And it turns out ARM 64 is not supported by GKI. Final point, somebody raised again in the Q&A some issues about whether GKI encourages out-of-tree modules. Didn't really reach any conclusion except that, yes, it probably does, but it's no worse than it is now. Another interesting talk from Muthiah from Google about technical debt. So by this, he meant the debt or the effort required by Google to maintain the Android Common Kernel patches. And they have a policy now to be close to mainline. So they want to reduce the number of patches on top of mainline Linux that they maintain, ideally down to 0, which again is a great thing. He gave this reference here to, if you want to track the number of patches that are out of tree, you can follow that link there to common-patches, clone that, and then you can see exactly what the patches are. So at the time of doing the presentation, he said there were 224 patches in that tree. I had a quick look earlier today. I counted 200, but I'm not 100% sure that I was looking at the same thing as he was. The point is, though, you can take this common patches patch series, apply them to mainline kernel, and you get the Android common kernel. Another interesting build from Muthiah on hermetic builds with Brazdil. So by hermetic builds, this means guaranteeing that you always produce the same binaries every time you run a build. And the current build tool with GKI, if you've ever used this, is called build.sh and is not hermetic. So it leaks lots of information from the environment, and so it will build different things at different times. So this is not so good. So they have switched instead to using Brazdil for kernel builds. So this is an Android 13. The Brazdil build system is sandboxed, therefore hermetic. They claim it's better parallelization and therefore faster, although when I ran a build just now, it didn't seem any faster to me, but maybe I'm not comparing apples with apples. And in the little bit down here, this shows you how it works. The main bit here is that to run the build, you run the Brazdil front end, and then you tell it to build the common kernel. And the particular variant you want is kernel-ARch64, for example. All of this stuff is encoded in this Brazdil file in the common directory called build.brazdil. Talk on virtualization from David and Serban. So this is in Android 13, and it is to introduce a hypervisor called PKVM into Android. The hypervisor runs a guest operating system called MicroDroid. So this is a cut down Android, no Java, just the platform code. In other words, just the C++ environment. And then you can create pipes using Binder to communicate between the guest and the host. Why bother doing it? This is what they call the protected computing environment. So any code you want to run, which you don't want to run in the native Android environment, you can run in MicroDroid instead. And they gave a couple of examples. And then there was an interesting quote on one of the slides, which is that the trust zone TEE, trusted execution environment, is too privileged and too fragmented to use. So in other words, instead of pushing stuff into trust zone, for those reasons, we now have a hypervisor environment, and you can push sensitive computing tasks into that. Here's a nice little diagram, which I stole from source.android.com. I'm going to skip over this because I'm running, well, I've run out of time. Give me a couple of moments, though. There was a talk on Cuttlefish from RAM. Nothing new here, really, just an overview of, or a review of what Cuttlefish is. Cuttlefish is an emulator used for kernel system, BSP, and CI testing. It works with hypervisors, including QEMU. Well, it works basically with anything that supports VirtIO, which includes QEMU, CrossVM, and Cocos from Open Synergy, who we will hear from in a little while. eBPF-based fuse. So eBPF is the extended Berkeley packet filter. And like I say, it's one of the common themes throughout Plumbers and also the Open Source Summit. So it just allows you to load code into the kernel at runtime. And I think it's best to think of it as being JavaScript for Linux, for the kernel. So I only threw this in here because it kind of fitted in with that theme. This particular group are looking at using eBPF to speed up some of the Fuse code that they use in Android. Fuse means file systems in user space. It is inherently slow because you have to transition to user space for every disk read and write. So by encapsulating some of that into eBPF, you can avoid some of those transitions, and therefore it should be faster. This whole thing was experimental. None of this is going to be shipping, well, is shipping in 13, and I didn't see any relevant, well, it didn't look like it's going to be in 14 either. EROFS, I'm not quite sure how you pronounce it. But this is a read-only file system, similar to Squashfs, for those who know that. It has some advantages of Squashfs, which are not particularly relevant right now, except that it is, quotes, better, unquotes. It's been in mainline Linux for some time. And so this talk was talking about, could we use EROFS in Android, and if so, how? And there was some examples given of how it can reduce the size of, for example, the system partition by, say, 45% if you do the right things. And they did some speed tests as well to show that there's no speed regression on using EROFS as opposed to ext4, which is what we currently use. And then the very fast slide, very last slide. Rust, like I say, was another common theme throughout the conferences. Very briefly, Rust is good. I think we could say, or at least as this, when it says Linux, it should say Linux. So Linux says Rust isn't terrible. In the end, it's not Perl. So Rust support will be merged into Linux in 6.1 in a couple of months' time. Just the minimal stuff. And then over the next few releases, we can expect to see device driver code being implemented in Rust. But there's no intention to recode the entire kernel in Rust, or at least not anytime soon. And that is quite literally it.